This test portion 6.3E, these questions. Let's go to page 118 textbook. Okay, we'll start in this class, we'll do this too. Okay, and then the next class, question number 8, page 118, class 9 maths, exercise 6.3. So B6, let me read the question for us. Let's go about it slowly. So there is a figure, so since the figure is given, let us draw the figure first. And the figure looks something like this, I think. Like this. Okay, and then this is the P. Okay, we can lessen it a little bit. Okay, this is the P, this is the Q. Then R here, and this is the arrow mark. Up to a segment marked here, S, with a point. And then this angle is bisected. So this angle is bisected means this angle is equal to this angle. This line bisects angle PQR. The question says that. And then here also bisected. So there the two will go and they meet here. So bisected, this line bisect P angle PRS. So this angle will be equal to this angle. Keep that closely in your mind, okay, because you're going to need that bisection property to prove. Okay, so this is T. That's all we have, I think. And so we can write down here given to us is, we can write in the figure that is given to us, or the one we have drawn just now from the given, this side QR of triangle PQR is produced to a point S, means to just write S, okay, to S, full stop. Then one more statement, bisectors means lines, bisectors of angle PQR and angle PRS meet at point T, means at T. We can just write like that instead of mentioning point also. So let us break up this bisection concept here. This TQ bisects PQR angle, that means this angle here, PQT, this angle PQT will be equal to angle TQR here, TQR, and both of them will be, we know now, half of the full angle PQR, the angle which it bisects. So if each of these two small will be equal to half of the full, that's the meaning of bisected. Okay, so this is equation 1. Let us put. Similarly, angle here, this also bisects this P angle PRS. So PRT, angle PRT will be equal to TRS, angle TRS. Both of them will be half of angle PRS. So we're going to need this at some point, I think, so we'll just write it like this. Okay, then we have to prove something, so let us write that. To prove here, angle QTR equal to half of angle QPR. So this QTR equal to half the measurement of QPR. That's what we have to prove. That means if this is 30, this is 60. This is half of this. Something in that line of concept we're going to have to prove. Okay, so proof means our answer for this. Let's keep closely in remembrance these two, because we're going to need this, I think. Before that, let us take this triangle PQR. We have learned this property in the theorem, exterior angle. This line is extended, means this compared to this triangle PQR, this angle will be exterior angle PRS. So angle, let's just write here, exterior angle PRS, this one PRS will be equal to the sum of the two interior opposite angles. So this exterior means the three angles inside are this and this of this triangle. So this is nearby, so this is not the opposite, these two. So this angle here, angle PQR plus angle QPR, and we write the property here. Since we know that property of triangle, exterior angle of a triangle is always equal to sum of the two interior opposite angles. So to this exterior angle PRS equal to the two interior opposite angles PQR and QPR. Okay, so next step, now we're going to have to prove this QTR, so equal to QPR. So this is there now here, QPR. So QPR, that you keep it, then PRS. So let us take this QPR on one side. Okay, so here, to make it similar to this here, to prove half, let us multiply everything by half. So you can write, if you want, multiplying both sides, not hard, okay, but we need to listen carefully, both sides by number half, you will get here half angle PRS, half angle PRS will be equal to half this angle PQR plus half of this angle QPR. Okay, that way we have at least got this one here, see, this one. So let us not touch this anymore, and then we shift here half angle without touching this, then you put this one half angle PRS and shift this one to this side, and plus will become minus half angle PQR. So at least we got this one settled, the right hand side of what we have to prove. And let us try to convert this half PRS, so PRS, okay, half of PRS. Let us express in terms, now we're going to have to take this triangle next, which is this exterior angle. So TRS, TRPR equal TRS, TRP, PRT, half PRS. So half PRS, let us express in terms of this, which is going to be the exterior angle of this triangle TQR. So PRS here, half PRS, this is not equal, okay, minus PRS equal to TRS. So I'm going to write here half PRS is equal to TRS. So I'm going to replace TRS minus half PQR. That one I think is fine, we can keep it like that, half PQR, PQR. Okay, let us express. Now we've done this PQR triangle here, see. Next we're going to focus on TQR, triangle TQR. So out of these two, this angle is inside the TQR. So let us take this one, TQR. So here TQR, TQR here, see. So half PQR, which is this, let us replace by this angle TQR, and it's equal to here half angle QPR. And let us write here reason for changing this to this using equations. Half PRS to TRS is equation 2, and changing half PQR to TQR, half PQR, so here see half PQR to TQR, we have used 1. So the reason for changing this to this is 1, this to this is equation, getting from equation 2. I hope that is clear to you. So let us put this one as equation number 3. Now let us take the other triangle as we were saying and apply the same property in triangle TQR, exterior angle TRS, this one here, this line is produced means this is exterior angle now, TRS is equal to the two interior opposing angles, angle TQR, this one TQR, and this one angle QTR, because we know again exterior angle in a triangle is equal to sum of the two interior opposite angles. Now here we have to have the QTR, so this is the one we said we don't touch, and shift the rest. Angle QTR, don't touch that anymore. Now here this one, angle TRS, shift this one this side, then minus angle TQR, plus will become minus, right? So now we have here TRS, same, minus TQR, exactly same, we got these two, exactly identical. So this is equal to this, so we can replace this one now by this one, half angle QPR is equal to angle QTR, and we write here, since using equation number 3, so hence proved. See here, QTR half equal to half angle QPR, right? So next, one more question, and then we'll do 8 in the next class. B7. Okay. Let me read the question for us. Not hard, but we need to listen carefully. In this figure, Q greater than this, PA is bisector of angle QPR, PM perpendicular. Okay, let us draw the diagram because it's given to us, I think. As given. So the diagram looks something like this. Like this, and then here a perpendicular is drawn down 90 degrees. That means here M letter, and PA bisects QPR. So this line PA, this line PA, I think A, this PA bisects QPR. This angle is bisected by this line. That means this angle QPA equal to APR. Okay, that is given. So let us write the given as given in the question. So given is, let's go about it slowly. In the figure, angle Q is greater than angle R. That's mentioned, I think, not so required for solving, I think. Anyway, PA is bisector of angle QPR, okay, bisector. So that means here that much is given, and PM is perpendicular to QR. Okay, so okay, so let's do like this. That means PA bisects QPR means angle QPA or APQ, whatever you like to put. QPA or APQ is same. APQ and APR are equal because they are bisected by this PA. That means bisect means divided equally into two parts. So that will be half of the full angle, angle QPR. This one is bisected. So let's keep this one as equation number 1. We may need it. Now let us start the solution. Means the answer. Now let us, the proof. I think this is a question to prove. So it's good to go like this to prove, which is not absolute necessity, but normal way of doing proving sums. Okay, so this angle APM is equal to half of angle Q minus angle R. So we have to prove that. So let us start the proof. Go about it slowly. Now let us take this triangle in right triangle PQM, because we know this is perpendicular PM. So one angle 90 degree means this triangle is right triangle. So this angle here, the other two angles, acute angles, plus QPM angle, QPM will be equal to 90 degree, because we know this property since sum of the two acute angles in a right triangle always equal to 90 degree. We know that in a right triangle, one angle is 90 degree, the other two are acute, and those two acute always put together 90, because 90 plus 90, 180, right? So this is the thing. Now at least we got this, so let us write this one. This one is gotten now, equal to, then here 90, then shift this one to the right side, then minus QPM. Okay, so QPM, just keep it like that for time being. Then next, let us put this one as equation number 2. Do the same thing. Similarly, in right triangle, the other one, directly we can do this one, PMR. We have taken this right triangle on the left, PQM, and PMR. 90 degrees this one, so the other two are MPR, angle MPR, plus angle R, this one here, will be equal to 90 degree, because we know just now we did sum of the two acute angles in any right triangle is equal to 90 degree. Okay, so let us do that. Now next, once we're through with that, then next here, so the shift like we did it, angle R we need, so we just don't touch that, equal to 90 degree, then we shift this one, minus angle, sorry, MPR. So just simple as that. Now here, let us put this one as equation number 2. Now see here, we got our, on the right side of what is to be proven, angle Q is there, we got it in terms of this, and R. So we can just put a minus sign in between. So how do you do this? Q minus R, to get that, we have to write subtracting equation 2 from 1 from equation 1. Now in subtraction 2 from 1 means not 2 minus 1, it is equation 1 value minus 2. Okay, it's 1 minus 2. So 1 is here, CQ. Left side minus left side, that is called subtracting 2 from 1 means 1 minus 2, Q minus R, equal to, so we have to start with right hand side also. 2 from 1 means 1 minus 2, so left right hand side of 2 first, 90 degree minus angle QPM, this one, then minus, because we are saying subtracting this one, so we need to put a bracket because this is minus 90 degree, then minus angle MPR. So Q minus R, left side, right side, 90 minus QPM minus 90 minus this one. So let us do this one, angle Q minus angle R, at least we got this, equal to 90 degree minus QPM angle minus the plus minus 90 degree. Now we can remove the bracket like this by multiplying outside and inside. So minus into minus, plus angle MPR. So that way minus 90 plus 90 gets cancelled. And so you're going to get here angle Q minus angle R is equal to, this is plus, so we may write that one first. And then minus, we can write second, which is not a rule, but we want, arranging it like that seems easier to deal, right? So this one, now we need, already got this one right side, we need a half in front of this, so that we have to manipulate here and get it. So let us do that in terms of APM. So try to change everything here in terms of APM, because that's what we need. So let us look, how do we do that? MPR, so MPR, we can write it as this small angle APM, angle APM plus here APR. So I write here angle APR. Look at it yourself. These two combined is this one or not? See here. APM, this small angle, APR, this one, together is MPR, this one. At least we got in terms of this one, see, APM. Now next, minus, bracket again, QPM. How do we change this QPM in terms of APM again, which we need on the left side? So QPM, we can write APQ. Listen carefully. Angle APQ minus this big angle minus APM. Then you will get angle APR or not? See, sorry, not APR, QPM or not? QPM. This angle is nothing but, so I can just write it like this, equal to, okay, that's fine. Now QPM, this big angle APQ minus this big angle minus this small angle APM, this one QPM, this one. So we have expressed it in that terms. So now we can write here angle APM plus angle APR, this portion, and let us remove this bracket, minus into plus, minus angle APQ, then minus into minus, plus angle APM. But that way we're going to get here APM plus APM is twice angle APM. So we also got this half again, because if you shift this 2, it will go down here 1 by 2. So we have to deal with this 2 part. How do you do? Let us see. So APR, here APR is there. So you may just choose to put that same plus angle APR. Then this APQ, observe here, APQ and APR are equal. So we may as well replace this APQ by APR minus APR. And we can give the reason here, since using equation number 1, which says APQ and APR angles are equal. These two are equal, APQ and APR are equal. So we can replace APQ by APR, because APQ is equal to APR. That way, why we did that is plus angle APR minus angle APR is 0. Plus 2 minus 2 is 0. So also plus angle APR minus angle APR is 0. So we're going to get here, this side, let us write once, angle Q minus angle R, we're going to get equal to twice angle APM. This is what finally we're getting. So one more step and then it's done. So next here, therefore, there is no number here, means angle Q minus angle R. We can always put thousands of 1 like this, so at least 1 we can put ourselves. Always there is a 1 factor, even if it's not written. Then this, if you shift this 2 into, then it will go to the denominator. So it goes here, and then that will be equal to angle APM. Now go and see your text. Proof angle APM equal to half angle Q minus angle R. So it's done, right? Okay. Next class we'll do 8, okay?